Hey Algebra! Happy Thursday! 2 more days until the start of winter break. I hope you're as excited as I am. So if you are following along with the schedule that I suggested, you have 10 problems to work today solving by elimination. If you're going on a different schedule, that's fine also. That's one of the joys of online learning, is that you guys can work at your own pace, more than you could if we were together at least. Most of the problems that you worked in the previous section were either you could just add them together and cancel a variable, or already had a variable that had the same coefficient or number in front, so you could just multiply by -1, change all the signs, and cancel. The last 2 problems weren't like that. You had to multiply not just by -1 to flip all the signs, but maybe a larger number to get one of the terms to cancel. The problems today are just like that. Let me work through a couple examples to help you get started and show you what I mean. For all these equations, there's multiple ways to solve them, whether you eliminate x or y as your first step, and then which equation you choose to put the variable you find a value for first back into. But I'm going to show you one way to solve them and the sort of general steps you can use to solve these when you're working yours. So I'm going to start by working number 11. Number 11 is -3x plus 7y equals -16, and -9x plus 5y equals 16. I'm going to start by eliminating x because y looks like it would be messy, and I have to multiply both of my equations by some factor. So I'm going to start by multiplying my first equation, and since I have -9x in the second one, I need my first equation to become positive 9x. So I'm going to multiply the whole equation by -3. And as I distribute that -3, it's going to give me 9x minus 21 equals -16 times -3 is going to give me positive 48. I'm going to bring the second equation over underneath it so we can line them up and add them together. So -9x plus 5y. Oops, I forgot to write my variable up here. And that equals 16. When I add those two equations together, my x's cancel, and that gives me -21y plus 5y, which is going to be -16y. And that's going to equal 48 plus 16, which is 64. I'm going to divide both sides by -16 to get y alone. And that is going to give me y equals -4. So now I know that y equals -4. So y equals -4. And we are going to solve for x. We can plug y equals -4 into either one of the equations. I'm going to choose the second one just because I prefer working with positive numbers. All right, so we're going to rewrite it, and every time there's a y, I'm going to plug in -4. So that gives me -9x plus 5 times -4 equals 16. I'm going to distribute and get rid of my parentheses, so -9x minus 20 equals 6. Going to move the 20 over by adding 20 to both sides. That gives me -9x equals 36. divide by negative 9, and that gives me x equals negative 4. So in the solution to this set of equations, both of our variables are negative 4. So the way I would write that is as a coordinate pair, negative 4, negative 4. I'm going to also work one of the problems that is a little bit trickier because there's no obvious number to multiply things by. So let's do number 17. So number 17, we have negative 7x minus 8y equals 9, and negative 4x plus 9y equals negative 22. There is not an obvious number that we can multiply one of these by to be able to eliminate one of the variables. So we're going to have to multiply both of them by something. If I try to get rid of y, I'm going to have to figure out a number that both 8 and 9 can go into. I think it might be pretty big, so I'm going to eliminate x first, and I am going to multiply my top equation by 4, and my bottom equation by negative 7. So let me factor those out to the left here. So negative 4 times negative 7x is going to give me negative 28x. Minus 8y times 4 gives me negative 32y, or minus 32y. And that equals 4 times 9, which is 36. My second equation, I'm going to multiply this negative 7 times the whole term. So that's going to give me positive 28x. Negative 7 times positive 9 is going to give me negative 63. So negative 63y equals negative 22 times negative 7. So that's going to give me a positive answer. 2 times 7 is 14. Carry the 1. 2 times 7 is 14 again, plus 1 is going to be 15. Alright, so now we're going to add those together. If you want to check your work with a calculator, you are more than welcome to, if that makes you more comfortable. It's important for me that you know how to do the steps. If you aren't comfortable with the arithmetic, I mean, practice if you can, but that's fine. Alright, so negative 28x and positive 28x are going to cancel. So we have negative 32 plus negative 36. So that's going to give me negative 95y. And that equals 36 plus 154. So that's going to be 191, or 190. If I divide both sides by negative 95, I'm going to get y equals negative 2. Alright, so we know y equals negative 2. You can then plug this into any one of the equations. I'm going to erase because I don't want to use any of these larger equations. I'm going to use one of the smaller ones. I'm going to use this first equation, and I'm going to plug y equals negative 2 into anywhere there's a y. So negative 7x. So negative 8 times negative 2 is going to give me positive 16. Y. Oh wait, no, sorry, positive 16. And that equals 9. So I'm going to subtract 16 from both sides. That gives me negative 7x equals negative 7. Divide both sides by negative 7. And I get x equals 1. We know x is 1, we know y is negative 2. So we write that as our coordinate pair, 1, negative. As always, if you need help, please send me an email, tag me on Teams, or come to office hours 11:40 to 12:25 every day. You can find the link in the same tab on Teams where you find the link to our class meetings on Tuesdays and Fridays. Bye!